Okay, so we've graphed exponential functions. The basic one, the parent, is y equals 2 to the x, which you can see the graph right here. Right? You just make your table. There is a horizontal asymptote here, and we have a basic table of values right here. You graph it. You can identify the domain range and asymptote. Today we're going to look at graphing a logarithmic function in base 2, but it could be any base. And this is a basic one, right? There's no horizontal or vertical translations. So you're going to start with a value, which I kind of have populated. But when you think about it, right, if you just randomly start with your table, and usually like with this one, with the table for the exponential, I usually start with 0 because 2 to the 0 is 1, and it's easy to work with. But over here, when I start with 0, right, what's happening is the logarithm or the function is basically saying this, which is basically saying 2 raised to what exponent is 0, right? Every time you do this, this is how you want to think until you really master the concept of the log. But this doesn't exist. You can't raise 2 to an exponent and obtain 0. So this is an undefined value, right? And then the next thing I do is I don't jump right to 1/2. I go to 1, right? So 1, when I put this in here, this is saying 2 to the 2 to what exponent is 1? That's your 0, right? So I have a point in my table at 1, 0, and then I go to 2, right? So this is now a 2. 2 to what is 2? Well, that's 1, right? Oops. That's 1. And then you can go to 3, right? I don't have 3 in my table, but if I were to use a 3, this is a little bit more complicated. 2 to what exponent is 3? I have no idea, right? I do know it's going to exist somewhere between 1 and 2. I just don't know exactly what it is, but you don't have to use that value, especially if you don't have a calculator accessible. Just jump to a new input x value that's a power of 2. So when you do this, your table of values, right, for your inputs here, these should all be powers of 2 because it'll be a lot easier to deal with, right? So instead of using 3, if I wanted to use 4, right, 2 to what exponent is 4? Well, that's a 2. It's an easy one, right? We can make sense of that. And just keep working through your table, right? So that's a 2, and then if it was 2 to what exponent is 8, well, that's a 3. If I wanted to do a half, 2 to what exponent is a half, that's a -1. You could even get smaller here. 2 to what exponent is -1/4 is -2, right? Now that you have your table, now we can start plotting it, right? So drop your points in, right? And you can kind of see this pattern happening. And then you're gonna sketch your graph in, right? So my graph is going to run through these points, and as these values here, right, 1/2, 1/4, as we get closer to this 0, right, you're going to start noticing that these y values here start getting closer and closer to -infinity. You can see that in the curve right here, right? It's going to basically shoot straight down, which means you have this asymptote here, right? And you can't go any lower than 0 right now. Right? Once you get to 0, it's undefined, but as we approach 0 from the positive side, so if you're reading the graph right now, kind of from right to left, this curve is getting closer and closer to that asymptote, but it never actually gets there, but vertically it approaches -infinity. This is the graph of an exponential function. And the interesting part about it is, if you look at the x values in the table now, right? All of these x values are identical to all of the y values in your table here. Right? And then also all of the output values, -2, -1, 0, 1, 2, 3 here, these are all the input values. So what you're noticing without direct instruction is that the graph of y equals 2 to the x is the inverse function of the logarithmic graph that we have. And we'll learn about inverses later, not right now, and that's not really what you need to worry about. I'm just drawing some connections for you. And then, lastly, which I just point out here, that these graphs are, they're reflected over the line y equals x, right? So if I graph the line y equals x here, the graphs for the exponential function and the logarithmic function are reflected over that yellow line. And that's a concept we'll focus on later. But for now, you want to focus on taking this log function, creating your table of values here, graphing your curve, and then domain, range, and asymptote for the logarithmic function. Well, the domain doesn't get any smaller than this vertical asymptote right here. So the domain's going to be x is greater than 0. The range for the curve itself is going to be all real numbers, and then this asymptote that's vertical is the line x equals 0, right? It shows up right there. So there's a few to practice on the assignment tonight, and then we can talk more when you get back.